In this video, we're going to look at prefixes. A prefix can be placed at the beginning of a unit to signify a certain order of magnitude. So you may know that you can put the word kilo in front of meters, for example, to get kilometers, and that will give you 1,000 meters. In physics, we're going to look at a specific number of prefixes today. We're going to focus mainly on kilo, mega, giga, and tera. But first, I thought it would be useful just to discuss the importance of prefixes and why we need them. So looking at the screen now, you can see I'm giving you some values here, such as the distance to Australia, which is 15,226 kilometres. Now, if I didn't use the kilo prefix there and have kilometres, what I have to be saying is that distance is 15,226,000 metres. It also makes it more difficult to write down, as sometimes the numbers would lose meaning in reports. In the same way that BBC Radio Leeds operates at a frequency of 103.9 FM, that's actually megahertz. But rather than saying 103.9 megahertz, I'd have to be saying 103,900,000 hertz. Finally, if we look at power stations' output, so the energy produced by a power station, a coal power station in this case, we've got 700 gigawatt hours per year. Rather than saying 700 gigawatt hours, I need to say 700,000 million watt hours. So you can hopefully see the need for prefixes to try and keep things simplified when we're doing reports and speaking about things in physics. So on screen now are some common prefixes that we use in physics. These are the ones that you need to know for GCSE. If we start at the base point here, this is where we'd have our original things such as a meter. If we go up from there, we go through the ones that we're going to focus on today, which are kilo, mega, giga, and tera. If you go beneath there, so you get smaller, you come with centi, milli, micro, and nano. They each have the symbols associated with them as a way to convert them. But today we're just going to focus on the ones that are larger than the original meter. So you can see these on the screen. I've highlighted them for you now. And we've got tera, giga, mega, and kilo. They go upwards from the meters. So 1 meter, if we get to 1,000 meters, well, that's a kilometer. And we can use a standard form of times 10 to the power 3. If we go greater than that, we can get up to 1,000,000 meters. That makes a megameter with times 10 to the 6. Going further still, we get 1,000 million meters, which is a gigameter, okay, which is times 10 to the 9. Or going up again, we can get to 1,000,000 meters, or terameters, which is times 10 to the 12. You should hopefully see in terms of standard form that this way they're all going up in threes. So how would you be able to convert from larger prefixes down to small ones, which is important here, because when we're doing calculations in physics, we need to be in our standard SI units, okay? So we need to be in the units that are given for us to use in physics. So when we're talking about meters, we have to be in meters when we're doing calculations. So if I have a value in kilometers, I can multiply by 1,000. If you're happy with standard form, that's times in by times 10 to the 3. Megameters, I multiply by 1,000,000, or I times by times 10 to the 6. If I have gigameters, I multiply by 1,000 million, or times 10 to the 9. And if I have a terameter, I will be multiplying by 1,000,000 million, which is times 10 to the 12. So we're going to have a look at some worked examples. Hopefully you've got a sheet with you that has these on. If not, you can always remember to fill these in your own notes. Okay, and it says that the first question, a wind turbine produces a maximum power output of 2.8 megawatts. Calculate the power in watts. So we've got mega. If you remember back on the previous slide, that was 1,000,000 watts. So to do this question, I'm going to take the 2.8. I'm going to multiply that by 1,000,000. And that will give me my answer, which is 2,800,000 watts. If you feel more confident using standard form, you could have just put a times 10 to the 6 there, rather than write out the million value. So that would be times 10 to the 6 watts. The next example is saying that a marathon is 42.195 kilometers. I want you to give the distance in meters. So if you remember back to the previous table on the previous slide, the kilometer is 1,000 meters. So I need to multiply that by 1,000. So I take the 42.195 and I times by 1,000. and that will give you an answer of 42,195 metres. Again, you could have used the power standard form symbol times 10 to the 6, times 10 to the 3 there if you wanted to. Okay, we're still moving on through these. So the next one says a microwave has a frequency of 2.46 gigahertz. Give the value in hertz. So remembering that gigahertz was equal to 1,000 million watts, 1,000 million. So using the same process as before, I'm going to say that this is going to be equal to, so we're going to do 2.46 multiplied by 1,000 million, and that will give me an answer of 2,460 million hertz. Again, rather than doing it that way, you could have used a symbol which was times 10 to the power 9 that time. And remember, you can leave your answers in standard form in physics. That's okay as a final answer. So if I was to write that as a final answer in standard form, the answer that I would have got, I'm just going to put up here, would have been 2.46 times 10 to the 9. And that would have been in hertz. Okay, so for the final question, standard form is actually much easier to do with the final one, but we will go through it as we would do if it was without standard form. So we've got 0.7 terahertz. So if you remember, tera is the large one that we're going to look at GCSE. So we're going to times by a million, so that's 12 zeros. Okay, and when we multiply 0.7 by that, we get our answer. Now, if you put into a scientific calculator, that comes out to be 7 times 10 to the 11 hertz, which is how I write my answer. So in physics, you're allowed to write your answer in standard form. If you want to see how that would look in terms of just the zeros, that would equal 700,000 million hertz. So hopefully you're all happy with the process of being able to convert from these prefixed values, such as gigahertz or megameters or kilowatts, and convert them into their base units, their SI units. So now that we've gone through all of the worked examples, you've hopefully completed those on the sheet here. There's some more questions for you to complete on the sheet now, so let us have a go at those, and then we'll share the answers with you afterwards. It's been really great to work with you again today. Thank you very much for listening, and I look forward to seeing you next time. Thank you. Goodbye.